This is the Revolve boss base tool, and the first thing that we're going to do is select a plane and create a new sketch. And we're going to put a center line in because this is a revolve. I'm going to select infinite length for the center line and vertical, and I'm going to lock it to the origin so it's fully defined. And then I'm going to put a circular cross section. No, let's have a polygon cross section. So I'm going to sketch a polygon out at a distance away from the center line. Put some dimensions on that. Make sure that that's fully defined. And there you go. All the sketch entities have turned black. We've got fully defined in the box down at the bottom here, so we can use that for a feature. So if we click on the Revolve boss base, it will automatically pick that center line that we sketched for this axis of revolution, and it's defaulted to 360 degrees. So if we OK that, we get this revolved feature, which is that polygon swung through 360 degrees to describe this solid. So a few other options in there. In the blind option we can set a number of degrees, so that's the same shape just through 180, and if we click on the feature we can see that 180 highlighted here. And if we have the instant 3D feature switched on, we can grab this little sphere at one end of it and drag it in real time, and even lock it to these increments. So one other option in the setup of the blind direction is that we can flip the direction from the sketch that we rotate, so we've got counterclockwise or clockwise. The other option that we can show in this example is the midplane option, which basically takes this figure, say it was 100, and it puts half of those degrees around the revolve in one direction, so it goes 50 degrees in that direction and 50 degrees in this direction. So it ensures that the sketch and the sketch plane remain in the center of the revolve. So if we OK that and make the sketch temporarily visible, you can see sandwiched in the center. So that's the revolve. In order to look at some of the other options, up to vertex, up to surface, offset from surface, we're going to have to put some more geometry in the part before we can do that. So I've already prepared a part here, and this one has a similar hexagonal shape that's been extruded this time, and I've created an offset plane away from one of the base planes, and then I've sketched some geometry on there. So if we go into the sketch, have a look at that sketch, you can see I've sketched this circle and I've sketched a center line as well. So there's a center line over here that happens to be locked to the end of the extrude. So if we create a new revolve from these, you can see by default it just wants to use the blind option, but we're going to change it to the up to vertex option and pick one of the vertices on this part. So if we pick this vertex, what it's doing there is it's revolving this profile that we sketched around this center line until it gets to such a point that it intersects with this vertex, or with a line which is between this vertex point and this center line. and then it terminates. So you can see it terminates there. If we select one of the other vertices, this one for example, if you trace a line from this vertex to the center line, it's a horizontal line, so you can just see that our revolve is terminating there. In this case, that's not the most useful option, but some of the others will be. Up to surface, for example, it's asking us to select surface. If we select this top surface here, click on OK, you can see that our revolve's begun around the center line that we sketched, but then when it intersects with this surface here, it terminates. And it's not purely that face, it's that face extended to infinity. So it terminates even when it's not touching that face. So it regards that surface as infinite in all directions. So some of the other options in there are offset from surface. Again, we've got this top surface selected, and we can enter an offset value. So same sort of principle, but it can leave a gap, or if we need it, we can reverse the offset and it drops inside the part by the same amount. So it's 2 millimeters past the surface.